little talk about how hacking works. I hope you will have some fun. I know that I'm the only thing standing between you and beer at the moment, so let's hope this will be entertaining. So before we get into all the hacking and all the nasty stuff, let me just say a couple of words about myself so you get to know me a little bit. So who am I? My name is Espen Sande-Larsen. I've had just about every role in the tech industry that you can imagine. I've worked on everything from support to be a CTO, and I've even been a hacker and stuff like that. So I have a very, very diverse background. I've been working for what's coming up on to be 30 years. But I'm also a musician. I release music professionally. That's a shameless plug. If you search me up on Spotify, maybe I can get a couple more plays. That'd be nice. I have 3 kids, which I adore, and I'm super geeky and super nerdy. And when I'm not working, I still do all those geeky, nerdy things on my spare time. So I keep programming and building stuff and doing all kinds of fun stuff. And when I'm not doing that, I really enjoy drinking beer and having conversations with like-minded individuals. And I work in this little bank in Norway. It's called DNB Bank. I know nothing about finance and banking because I work in a division called New Tech Lab, which is kind of this crazy R&D department where I get to spin up crazy projects and crazy ideas. I love what I do. And since I work at a bank, I have to give this disclaimer. This is a bunch of stuff that basically says that, well, everything you're about to hear is me saying and not the bank saying. And you may notice that something is missing from this slide. That's usually jet lag is really kicking in today. Something is missing from this slide. Usually there's some academic accolades. None are listed because I don't have any. That's because I got kicked out of school when I was 16 and I started working, and I've been doing that ever since. And when I was 16, I found out there were 2 things people were willing to pay me money for. One was performing music and the other one was writing software. And I thought, wow, that's a scam. I can make money writing software. Wow, that's the best thing ever. And you may ask yourself, what on earth made it possible for a 16-year-old kid to take up programming and write software for a living? Well, it started with this thing. Anyone know what this is? Yes, it's the excellent and most beautiful machine that was ever conceived. It's the Commodore 64. I got that when I was an even younger kid, about 6 years old. My big brother came home with that thing under his arm. He was so excited. He yelled my name because he had just gotten that in a drug deal. He had traded some drugs for the Commodore 64, and we plugged that thing into the TV, and we didn't understand a thing. Because when you get like a computer on the black market, you don't get the best support package, so it didn't come with any manuals and stuff like that. It came with the power lead and the RF cable, and we didn't understand a thing. And it will take the next years of our lives to figure out how that thing worked, and wow, what a journey that was. And I've been in love with computing ever since. So I was hooked on building software, not on drugs. So let's get into the details of hacking. But before we discuss hacking, let's define what it is, what it means, because it used to mean something different back in the day. Because back in the 80s, it used to mean something else. And before I define it, let's see if Hollywood can show us how this thing works, right? Because surely they have to do some research. They make multi-million-dollar projects, right? How about television? This is a show called NCIS, and there's a hack in progress. And the way you know that is because you get 1 million pop-ups on screen. So let's see.
No way. I'm getting hacked.
A port scheme?
Of course you're getting hacked.
No, this is major.
And what's better than
They've already
defending
burned through the NCIS public firewall.
Well, isolate the node and dump them on the other side of the router.
I'm trying. It's moving too
have 2
fast.
people defending on the same keyboard. Because that's how keyboards work.
We're using our connection to the IFS database. Sever it.
I can't. It's a point attack. He or she is only going after my machine.
It's not possible. There's DoD level 9 encryption. It would take months.
This is the boss.
What is that, video game?
No, Tony, we're getting hacked.
They get into the computer. The entire NCIS network is next.
I can't stop him. Do something, McGee.
I've never seen code like this.
Not me neither, because that's not real code. That's it is.
Where'd it go, Abby?
I didn't do anything. I thought you did.
And of course,
No.
the non-technical person is the one who said today. by unplugging that computer, because all essential files and information the hackers were after was on that single terminal in the lab, of course. But how about another show about forensics, CSI? Surely they have to get this right, okay? Let's see. Listen to this gem.
For weeks, I've been investigating the Cabby killer murders with a certain morbid fascination.
This is in real time.
I'll create a GUI interface using Visual Basic. See if I can track an IP address.
I'll create a GUI interface using Visual Basic to find an IP address. Okay, I can't comment on that. That's just too silly. How about a movie that's called Hackers? It's the thing the movie is about. Surely they had to do some research. Look at that keyboard.
There's a new virus in the database.
That's how viruses work.
It's replicating, eating up memory. What do I do?
Type cookie, you idiot. I'll head him off at the pass.
We have a zero bug attacking all login and overlay files.
Run antivirus. Give me a systems display.
Yeah, there's your systems display. Look at that thing. Let's shoot the hackers in 3 dimensions.
Die, dickweeds.
The rabbit is in the administration system.
Send a flu shot.
Rabbit, flu shot, someone talk to me.
A rabbit replicates till it overloads a file, then it spreads like cancer.
Cancer?
Yeah, of course, we all have these circular keyboards, right, with no symbols on them. That's, yeah. Oh, how about a show that's made about a real hacker who actually lived? That surely that they had to get it right. This is my favorite nonsensical hacking thing ever I've seen on television. It's from a show called Scorpion. And just to set the scene, there's malware on an airplane and they have to patch it. So this is how you do that. You race after the airplane in a Ferrari, and some poor person from the flight crew has to climb down the landing gear with an Ethernet cable, because that's the only way to patch that airplane.
Drop the cable! Drop it now! Come on, you gotta get it!
I don't understand why he has to spread, because as soon as you let go of the cable, it's so much longer.
Okay, it's downloading. It's downloading.
What'd you say?
I don't know. A few seconds. It's a few
We're running
seconds.
at a roll!
Downloading. Just a few seconds. Almost. Oh, no. It's going.
That's a strong Ethernet cable. So yeah, that is horrible. And I actually tried to get my boss to approve a PO for a Ferrari in case I ever needed to patch an airplane, but sadly that didn't go through. So, okay, now enough of the nonsense. Let's actually talk about what hacking really is. And as I said earlier, it used to mean something different. Because back in the 80s, a hacker was someone who actually just tinkered with stuff and tried to do things and make things do things they weren't supposed to do. It wasn't necessarily any malicious things going on. Basically, it was all about thinking outside the box and trying to make the best of the stuff you had. For instance, my favorite example of this is Steve Wozniak, who made the Apple computer. He figured out a way to manipulate a video signal to the CRT screen, and it misaligned the electron cannon, so it hit the phosphorus at certain angles, and that created a color display that he can consistently make colors. So he could make a color display without having a video chip, and that was pretty cool. But what we refer to as hacking today, the malicious kind, was originally known as phreaking. And the reason that was called phreaking is because you used the phones, and if you were good with the phones, you were a freak. And because back then, computers weren't on the internet like they are today. You had to actually dial up a computer on the phone if you wanted to talk to it. And the thing we are actually talking about in the scope of this talk is that we are trying to exploit systems through their vulnerabilities. So just a little audience poll, because this talk can take a couple of different turns. Who of you are programmers, coders, by show of hands, or you write software for a living? Cool. Any architects, tech leads? You work necessarily not with code, but more PowerPoint and whiteboards? Cool. How about security engineers, pen testers, CSOs, hackers? Oh, we have one. Awesome. Ah, okay. Cool. And something else, Scrum Master, Project Manager. Okay, a couple of you as well. Let's talk about the different kinds of hackers, because they are usually motivated by the color of hats they wear. So these are the different colored hats hackers can wear. You can just look around the room and you can see there's my gray hats, my green hats, my blue hats. And of course, we have the black hats. That's the malicious kind. Those are the ones who do bad things. They do phishing campaigns. They do malware and all sorts of bad stuff. We have the white hats. That's your pen testers, the ethical hackers who does this for money, but you ask them to. Then we have the gray hats. They're not necessarily malicious, but they will still break your system, but they will disclose their findings and hope to get rewarded. Then we have what I hope most of you will go out of this talk becoming today, the green hats, the newbie hackers who have just started their excellent hacker journey. We have the red hats. Those are the ones that hunt other hackers and take down hacker organizations. And we have the last special kind, that's the blue hats. And those are hackers who are like invited by big companies to evaluate new versions of software before they are released to the wild. For instance, Microsoft has hosted these blue hat events every time they release new versions of Windows and stuff like that. So let's talk about why hacks happen. Because they seem to always happen and they seem to cost us a lot of money. And why shouldn't we just make sure that that cannot happen? And the reason is that we are humans. We make mistakes, and we do not necessarily make mistakes on purpose. But the thing is that modern software systems are quite complex monsters, and the devil is in those little details that we might have overlooked. I'm going to show you some examples of that afterwards in the demo section. And one of the reasons this also happens a lot these days is that now we seem to trust other people's code like it's the best thing in the world. Just think of all the libraries you use, all the frameworks you use. Have you ever had like a Node application with like 10 lines of code, but you look inside Node modules, there's like 7 million lines of code of other people's code? And you can't have all that in your head. You can't have all those details inside your head. Sometimes we developers, we kind of get married to our tools and we love them so much that we try to use them for everything, even though they are not necessarily intended to do so. I like to use the example that if you're building a house and you're so good with your hammer, but you need to pour the foundation, you will still use your hammer to mix the cement because it's so familiar to you. And now I'm going to share a story about a time when I got hacked, because I really got hacked once. And this cinnamon bun picture is going to make sense in a little bit. So this was some years ago. It was before clouds, but it was in the dawn of the internet. And I got a new job. I got to be the CTO in a startup. And we were going to take over the world. We had this newspaper ad solution thing, where we had advertisements on every web newspaper in Europe. And we would link these ads together so that we could have like cross newspaper ads where you can register a profile, you can play games and win prizes inside the ad. And we would get like this barcode that you can take to a shop and get your prize. And we can also then measure what else you got and all of that nice stuff. This was also pre-GDPR, of course. The problem is that when you're the CTO in a startup and you're trying to take over the world and build this distributed big system, you're also the tech lead, the principal architect, and the sole developer. So I was like this one-man development team, and I had to come up with this thing all by myself. And of course, there wasn't any clouds, but I still had to build this system. So I would travel around Europe and the US and set up data centers and kind of build my own mini cloud. And this was a real-time distributed system, and it was quite complex. And there was one problem, the client side. Because back then, if you wanted to do rich media with games and stuff in the browser, there was only one thing you could use. Any idea what that was? Flash, yes, of course. For those of you who don't know what Flash is, here's a crash course in Flash. This is Flash. That's your IDE. And if you take a close look, you see that this IDE has some strange tools that normally aren't present in an IDE. You have drawing tools, and you have a timeline for making animations, because Flash wasn't really made to create like secure applications. It was made to create these like interactive presentations that you can share with your friends or give to your coworkers as like these nice corporate presentations and stuff. And I thought, well, it's fine because it compiles into a binary format, so it should be nice. What I didn't know was that it was really easy to reverse engineer. And what happened was that we had this big campaign that was going on in Sweden. We had this convenience store chain that had like this fly swatting game where you had to kill flies, and if you killed enough flies, you got a free cinnamon bun. And one Swedish student did just that and reverse engineered my binary and figured out the backend call. And he created an application called the Cinnabon Generator, which is shared with his student friends on the forums of Sweden. And I got a very, very early morning call from a very angry CEO because one student had picked up 73 cinnamon buns in one single day. My immediate response was, well, that's a lot of cinnamon buns. That person really enjoys their cinnamon buns, which my CEO didn't think was funny at all. And then I had to stand in front of the board and go like, oh, it's my fault. It's never going to happen again. And I got sick of getting yelled at. So I came up with a plan how to fix it. So I said to the CEO, you go to Sweden with a big case of cinnamon buns, find this individual, bring the newspaper, get a story where we thank this person for plugging the hole in our security. That was kind of my impromptu bug bounty program that I invented. And she did, and we got a big double spread in the newspaper to show how we thank this individual. And I gave this talk in Sweden a couple of months ago. And after the talk, a guy came up to me and he was like, you're the cinnamon bun guy. And I'm like, whoa, yeah, I'm the cinnamon bun guy. Yeah, I wrote my master thesis on your colossal failure. Awesome. Oh, cool. Now that thesis is now part of the textbooks in Sweden, so my failure is now literally the textbook example of what not to do. So I get to teach generations to come of what not to do. So I thought I got a kick out of that. So how can we prevent these things from happening? And I am a big fan of learning these skills inside your dev teams, because if you know how to break stuff, you will build much more secure software. And a great way to gain these skills is what's known as CTFs. Do you know CTFs? Awesome. For those of you who don't, I will let Elliot from the excellent TV show, Mr. Robot, the one show that actually gets hacking kind of right, define it for you.
A CTF tournament. Capture the flag. It's like the Hacker Olympics. Teams around the world compete to solve challenges. Reverse engineering, protocol exploitation, forensics. The entire city's suffering an energy crisis while they're here exercising their inner anarchy.
So it's a gamified way to exercise your inner anarchy, and that's kind of fun. I love CTFs. So CTFs, it stands for Capture the Flag. The point is you solve different challenges that encompass one aspect of some kind of security flaw, and your job is to find a little secret called a flag. And it's a gamified way to learn these adversarial techniques, and it's very, very cool. I can't see anything. Yeah, who cares? It's a great catalyst for learning. And we have actually had CTFs in DNB Bank a couple of times. And it really enables you to think differently. And we had some great experiences because we opened it up to the entire group, not just the tech teams. And I actually got the awareness of cybersecurity was so on the agenda that everybody was talking about hacking and cybersecurity. And that was pretty cool to have in the entire group. And we had like these great conversations over everything. And my favorite email that I got in DNB Bank was from a lawyer in the legal department who wrote me a letter of apology because he had performed a SQL injection attack on my server and he had accidentally deleted the database, so he felt sorry. And when lawyers in a legal department are performing SQL injection attacks, you're doing something right as an organization. And it's really just fun to play the bad guy for once. It's really fun. So these challenges come in different categories. The aspect is to give you an idea on what kinds of skills you need to solve this challenge. So we have crypto, which is all about breaking codes and encryption. We have stego, which is about finding something hidden inside something else. It could be binaries inside images or images inside binaries and stuff like that. Forensics, where you get to do some data mining. You can analyze network traffic logs, file systems, everything to find the secrets. And then we get into the things that are more like real hacking, like reverse engineering, where you have to figure out how a program works and identify the vulnerability and exploit it. And then we have one category that's usually called vulnerabilities because it's all about third-party vulnerabilities, like other people's code that you are using that is insecure. And then we have the creme de la creme. We have the web, the web thing, which is everything web-related because there are so many different vulnerabilities when it comes to web. And then we have the creme de la creme, that's pawning, where you actually get to take over an entire service and you get to execute your own code on that service. There's different kinds of tools. I'm not going to go through them, but these are a bunch of tools that you can use for different things. There are tools for everything from mapping network ports till cracking passwords to reverse engineering. One of my favorites on this list is Gira, which is this reverse engineering program from the NSA, which they have graciously open sourced and released to the world, which is kind of awesome. Let's talk about web exploits, because the web has evolved over the years from something it has evolved into something it wasn't conceived to be. Because this guy, this is Tim Berners-Lee. He invented the web. He envisioned this like library of linked documents where you can share research and stuff like that. But that's not what it has evolved into. It started with static content, but that transitioned into dynamic. And then we got interactive content, and then we did probably what some people would say was the worst idea ever. We let non-technical people free on the web. And now it's the primary global application platform that we use today. Most applications these days are web apps in some kind of form. And this introduces new vulnerabilities and new challenges. There are actually so many web exploits. There are everything: cross-site scripting, SQL injection, template poisoning, prototype pollution, misconfiguration, broken authentication, and a bunch of other stuff. There's actually so many that we decided to create an organization called OWASP to track the threat and the risk of different web exploits. Stands for the Open Web Application Security Project. And they got founded in 2001, and they publish awareness about application security. And they regularly publish these top 10 lists of the most risky things on the agenda that you should always be sure to protect against. And those are basically the most critical security risks that are relevant today. And there's also this thing called the CVE database. It stands for Common Vulnerabilities and Exploits, and it's this nice treasure trove of goodies. It's a public repository of different known vulnerabilities. There's POCs, there is how they work, and whenever a new one is disclosed and it's put into the database, it gets this identifier, the CVE, the year it was discovered, and some kind of serial number. And we use them for risk assessments, but for CTFs, it is a treasure trove. It's like this nice library of things you can do and exploits you can perform. There are different CTFs that you can do. Hack the Box, Try Hack Me, Pico CTF are these services that you can subscribe to, and you get different challenges all the time. Google has a yearly CTF, which is that's almost like the Olympics because it's really, really difficult, but it's really fun. OWASP publishes this Docker thingy called the Juice Shop, which is this Docker image of a web app, which is basically the least secure web app ever constructed, because it encompasses all of the top 10 flaws, and your job is to find them by doing it. I'd really recommend, if you want to start lightly with this hacking thing, grab some beers, grab some pizza, take your dev team, download the Juice Shop and have some fun. It's really, really fun. In DNB, we have had Hack the Bank, which is a CTF that I made. And we have had that open to the public and inside the group. I actually did a Christmas calendar with a hacked day last year, where every day there was a new service you had to breach. Pretty cool. And of course, the big security conferences like DEF CON and Black Hat has CTFs all the time. So enough talking. Let's go on to some demos and see some hacks actually happen. So now I'm actually going to try and do this live. So hopefully the demo gods are on my side today. So I've created a CTF. It's called VCH hack. That's just my handle, working class hacker. And it's this CTF. You can download it. It uses Docker. All you do is download it, run Docker Compose up, and you're good. Please don't open it to the public because it's super insecure by design. So be careful. So I'm going to log into my little CTF and find some challenges. Okay. Yes, it's me. Come on, Windows. There we go. So we have different challenges. These are different challenges. They are in different categories. And let's see if we can find some fun ones. Let's do... Yeah, we can zoom in. Let's do... Where are you? Yeah, let's do this receipt uploader thing. That's one of my favorite ones. Let's see. So it says, who doesn't love PHP? Can you think of a way to take over this site? So we can click open. We can click open. And we get to this marvelous, stunning piece of web app that we get to do something with. So it said something about PHP. I can take up my terminal and I can run whatweb, which is this tool that gives me some information. It takes all the response headers, sums it up, has some database. Yeah?
Can you zoom in on this text as well?
Yeah. Yeah. Is that sufficient? See again. So it says we are using Nginx on Ubuntu, and it says we are using Bootstrap. And it says it's upload your receipts, but we already know it's PHP. So what can we do with this thing? So let me just, I forgot to hack web demos receipt. Okay. If I just start to remove this. I forgot I had to prepare the demo. So bear with me while I reset this. There we go. So we have this, I have a picture of a cat. I can upload that cat. I can see I have uploaded the cat, and it says that this is a genuine JPEG. And I get the link to the cat, and yeah, that looks fine, right? Wouldn't it be cool if I could just upload a PHP file? So let me show you this one. PHP. So let's say if I try this. This tries to show me the PHP info. It lets me do a shell exec. If I can upload that, that would be beneficial, right? From what I'm trying to achieve. So let's see this PHP file. What happens then? No, it's an invalid image, so it upload failed. What if I do this exploit? This. What if I add? You can't see it, but if in the first 16 bytes up here, there's the header for the JPEG file. Maybe it just checks the magic number. What if I do that? Will that work? And if I do that, it will not work because it actually tries to parse the image. So we have to figure out something else to do. Luckily, images, even though they have binary data, they also have plain text data. Do you know what it's called? Metadata, yeah, or EXIF, as someone said. So if I go use EXIF tool and I take my cat, you can see there's all this kind of plain text data. It's the camera it was used, or how big it is in dimensions, and a bunch of stuff. But the cool thing is that I can add something. to this. So if I add some, get the right keyboard. If I just add this coding live in front of people, like this, and I add that to the cat. I add the comment, and I give that comment some PHP code. So if I now check that cat, you can see I have PHP info inside that comment. If I upload that, what do you think happens? Well, I have the picture of the cat. If I click it, does anything happen? Sadly, still not. I have to figure out how to lure this server. But think about how is PHP configured? How does the server know it should interpret a PHP file? It's usually because just it uses the extension. So if I change this extension of this cat, so if I do this cat JPEG and I call it hack, how hacking works, cat PHP, I probably can trick the server into evaluating that thing. So I called it this, and I upload that thing. Oh, come on, upload. Still an image, but if I click this now, PHP does what PHP does best and screw everything up for you. Because the web server goes, oh, this is called PHP, I better send that to the interpreter. The interpreter goes, I don't know anything about this binary stuff, but hey, PHP, I know that. Boom, there we go. And of course, now I can build that exploit further. I can list files, I can do whatever I want. I'm going to leave the rest of that to find the secret as an exercise for you. So let's check out another one. Let's do another one. Should we do, how much time do we have? How much time do we have? 30 minutes, good. We can do a bunch of demos then. So let's do this, bingo. And it says, make a guess. This is not normal bingo. All you have to do is get one right and you get one present. So I can test something here and of course it doesn't work. Again, I can see that we're doing PHP again. I can do some web to see what we're working with, if that helps us in any way. It seems that we are doing PHP 7.3.3.3, and we are on Debian Linux. Maybe that is something we can do something with. Let's inspect this form and see what's going on. So it sends a post request to index, okay. And there's this link here that says that we should ignore. We probably should not ignore that. We should click it and see what is going. Maybe this is something that somebody forgot about, and this highlights the index source code so we can see what's going on. And this site has this regex thingy that it evaluates, and if it sees config PHP in the URL, it will, yeah, I can zoom in. And it says that if you do that, you didn't say the magic word. And if it sees test in the query string, it will highlight the file by using basename. And basename returns the trailing end of a path. And we can see that the secret we are supposed to do is just one big random number. So that's not what we're looking after. What we're trying to do now is trying to figure out how we can access this config. And regex is this thing that I always think that this year I'm going to learn that properly, so I know what I'm doing, but sadly I never get around to it, so I just use this nice tool, which called regex 101, which tells me everything. I probably could have figured this one out, though. It's pretty simple, but let's see what it does. So it matches config, this literally, it matches the dot literally, it matches PHP literally, and the / literally. Then it does a greedy thingy, so you can have as many slashes as you want. And then it does this assertion that it asserts it's the end of the string. So if I do index PHP, I do /config PHP, and I do a bunch of slashes, that matches that thing. So how do I bypass that? Put in a query string, yes, because that assertion makes sure that it's that. So if I do that, I can at least try and access config PHP. So if I take that test probably it will highlight that file, right? That'd be nice. But again, it says, ha ha ha, I didn't say the magic word. So that didn't work. What if I add something else to this? Does that work? Well, then it says failed. It says highlight 23 doesn't exist. So I bypassed the regex, but now we try to find the file 23 based on, I can't zoom in on that thing on the top. But I put 23 in the path and base name returned 23. And that's that. So how can I get base name to return something else? So let's check out base name. Let's see what it does. So it returns the trailing component of a path. Okay. There's some examples, but here is this a nice big yellow box that says caution. Base name is locale aware. For it to see the correct base name with multi-byte character paths, the matching locale must be set using set locale. If path contains characters which are invalid for the current locale, the behavior of base name is undefined. Undefined behavior, that's something that's fun, right? So let me see if I can show you something. So I've just devised a little test here just to test these characters to see how base name behaves. So basically I set up a loop where I loop through that URL and I add a byte to it to see how it behaves in URL encoding. And I've written this little Docker script who just sets up the same environment that I found out through WhatWeb. So I have the same version, the same server, and the same type of distribution of Linux. And I just run this and just give myself a shell. So let's see. Yeah. So I'm going to do this almost without the ports. I'm going to just build that Docker container live, and I'm going to run it interactively. And I'm going to just remove it right after I kill it. So let's go inside this Docker container. Come on. There we go. I'm inside the container. Here is my test file again. And if I run PHP test, I can see how base name behaves. And I can spot if there's something interesting that I can do. And we see that base name returns, as long as there's an ASCII character, base name returns that character. But as soon as we are outside the scope of ASCII, it starts returning config PHP for some reason. Why? We don't know, because the behavior is undefined. But it probably gets confused. So if I take that thing, so all I need to do is take that config PHP, and I just add some kind of outside the scope of ASCII thingy, and I tack on test. Boom, I get config PHP. And I can see that the flag and the secret is there. So that's how that goes. So let's see if we can do some other ones. Let's leave PHP and let's do some JavaScript. Those are fun. Let's do the calculator. This is an awesome calculator. You can see it's a scientific calculator. We can do math. We love math. So 7 plus 9 equals 16. That's correct. And I can also let's see if I can check out the network tab, because this is going to be a little bit interesting. Because I can also set a variable. So I can do A equals 1. B equals 2, and C equals A plus B. And if I send that in, I get an object in return. And if I hit evaluate, I can see I get a result set, 1, 2, 3, because that's those 3 things that I sent. And I can see it's using math.js. So that means I know the library that they're using, math.js. And math.js is open source. It's I can go on the GitHub and I can read the source code. And if I read the source code, I can figure out how it's evaluating this thing, because for some reason it's evaluating code on some level. But I can't do like I can't do console log, for instance, because that is flagged as bad. So it has some kind of defense, as you can see the error. But after digging in that repository a little bit, I found out that, let's exit the container. I found out that you can, calc, come on. You can actually do some nasty stuff. So if I do a POC, I see here that if I do this thing, I can overwrite the constructor to the cost function, because the constructor is a prototype property on a JavaScript object, and if you send that a text of code, it will overwrite that function with the new code. Why? I don't know, but that happens. So, and I set it as an immediately invoked function as well, because this will return a pointer to that function, and since I am evoking it, that should return 1. And if I do that, I can see I get a result 1. So that means it ran that code and evaluated. And now I can do some nasty stuff. Because what I could do is, let me do, have it here, my notes. So if I do, let's see, copy paste. So if I do this exploit, let's do clear the screen. Let's see if I can show you. So I am overwriting that constructor. I'm getting a reference to child process through require. I run spawn sync. I give myself a shell, and I execute ls command, and I get the outputs. So it will now open a new process on the server, list out the directory, and show it to me in the calculator, hopefully. So if I run that, yay, these are the files on that remote server. And now I can build that exploit further and find the secret and stuff. So that's pretty neat. I'm going to show you one more. I think we have time for that. So let's do the serial killer, because that is one of my favorites. So we have this awesome website with, we'll just make this a little bit so we can see. So we have this website of the most wanted people on the North Pole. This is from the Christmas calendar that we made. So it was this theme about the Grinch versus Santa Claus and all the different kind of mythical characters. So that we have this big story on. But we can see this site. And if I do a what web again, what web? Ooh, come on. We can see that this thing is powered by Express. We know now that we are in Node.js territory, and that can be really fun. So it says I'm logged in as Santa Claus for some reason. And if I do some digging, I can find that there's a cookie being set called package. And if I take that cookie, I can see it's a base64 encoded string. So if I do base64 decode on that thing, we can see that we have this object in JSON format. So what do you think the chances are that this thing is coming from the server? Because if I do inspect on this element, I can see there it's just there as plain text. So for some reason that username is probably rendered server side. So if I go to encode, let's test if that is happening. So if I do Espen instead of Santa Claus, let's do Sydney, and we encode that. I take that thing, so now I just put my name as the username. If I replace that cookie, did I not? The padding. Of course, we need the padding. Okay. So if I now replace that cookie, client side, and I do a refresh, that cookie is sent to the server. And if it's evaluated by the server, we can see that this logged in user, which is now nobody, since I deleted the cookie, should change, and now I'm Espen. So you may also say, why on earth could that be dangerous? Well, I happen to know of a little library that does serialization in the Node world. So imagine you are new to developing Node, and you have to serialize an object. And you think, well, I probably need the library for that. So you Google Node serialize or unserialize or whatever. And you discover this, which is an NPM package that's called Node Serialize. And it seems, since it's called Node Serialize, it's probably the official one, right? We can see that it has almost 1,500 weekly downloads this week. It peaked in January. Let's see. Oh, come on. Why is it so slow? It peaked in January, almost 8,000 downloads. And let's see what it says. The headline says, serialize an object, including its function, into JSON. And that may not sound dangerous, but that is a horrible idea. Because why would you want to serialize behavior and not just data? And here's how it does it. There's an example. We have an object with the name Bob, and it has a say function. That function is serialized, and when you deserialize it or unserialize at this say, that function is preserved. And that is a really bad idea, because JavaScript has this nice thing with functions as first-class citizen, but it also has immediately invoked functions that we saw in the calculator, meaning that when the server deserializes an immediately invoked function, it will just execute that function right away. And this is now it's not a flaw, it's actually a feature. And if we go to the GitHub repository of this thing, there's basically this big security warning that says, please don't use this library. But still, 1,500 people are using it this week, new people. That's scary. So let's see how scary that can be. So I'm going to set up Putty. I'm going to set up a remote VM. Let's see if I can make the text bigger here as well. Change settings, appearance, change, let's do 20 point. Yeah, there we go. So I'm going to just set up Netcat with a listening socket on port 1333. And I've set up a little exploit. Let's see here. I'm going to show it to you. If I find it. Serial. So let's do this. I'm going to show it to you. Come on, VS Code. So here it is. So I just, how do I, that's not that way, so come on. So basically it's just an object, and I've read the library, so I figured out this is how the internal syntax is of that library, how it serializes the function. It gives me a spawn sync to a child process. It spins up bin bash, and then I pipe a socket to my VM that has a listening socket, and I immediately invoke it. So if I take that thing, and I do base64 encode, it should do something very, very naughty. It should call back to my server and give me a pipe. Open socket, let's take that. And I will just replace the cookie. Let's see. Replace the cookie like that. And before I run it, we notice I'm listening, and I'm on Arne at Azure user Arne. So if I refresh this thing now, it says I'm logged in as WCH, which is me. And now I'm suddenly at Node at some kind of thing, which means that I'm now inside that container. It called into me and say, hey, here's a shell for you. That's nice. So I can do all sorts of bad stuff. I can see the web server source code. I can see what's in the root directory, and there I can see there's a flag, so I can cut out that flag. TXT, and it says, wow, serial killers are deadly. And that's the secret, and that's how you hack that thing. So let me just wrap up this thing and see if we have time for some questions as well. So what I want you to take away from this thing is that CTFs are fun, and it's really good to learn these kinds of skills because it will enable you to write better and more secure software. Because when you know how to break stuff, it's easier to think about what you're doing. And you should also be aware of using third-party tools and not just use them because they seem like a good idea. Try and actually vet them and see that they are doing what you think they are doing. And I want you to go home, be curious. I want you to try and break your own stuff and foster your inputs and test your apps yourself. And I want you to put on your hoodies and go and be hackers. And if you want to download my CTF, it's on GitHub. It's open source. It's there. Have fun. If you want to follow me, this is what I look like from behind. Or you can do it online as well. These are my two things that I do online. There's my GitHub and my LinkedIn. And thank you. That was everything I had for you. Any questions?